The most important topic is the types of feedback amplifiers. In a single video, how to remember all the types of feedback amplifiers block diagrams in a easy way that I am trying to explain you. Remember this, this is very important topic. We may cover complete chapter. Types of feedback amplifiers. First one, we have 4 types of feedback amplifiers. Voltage series feedback amplifier. Voltage series feedback amplifier. First one is voltage series feedback amplifier. Second one is current series feedback amplifier. Current series feedback amplifier. And third one is voltage shunt feedback amplifier. Voltage shunt feedback amplifier. Voltage shunt feedback amplifier. And fourth one is current shunt feedback amplifier. Current shunt feedback amplifier. 4 types of feedback amplifiers: voltage series feedback amplifier, current series feedback amplifier, voltage shunt feedback amplifier, current shunt feedback amplifier. How to remember the basic block diagrams of those 4 feedback amplifiers block diagrams? I will explain in easy way. Go to first one, voltage series feedback amplifier. Voltage series feedback amplifiers. So here we have one amplifier that is representing with A, and we have another feedback network beta. This is common for all the 4 types of feedback amplifiers. Open loop gain A, that is belongs to amplifier, and beta feedback network. Here we have to connect both input side and output side sources, and we have to connect. For example, this is voltage series feedback amplifier. If it is a series feedback amplifier, remember that if it is a series feedback amplifier, compulsory the source is voltage. The source is voltage, very important. So here we have to take one source, that is voltage source Vs. If it is a series feedback amplifier, any series feedback amplifier, we can take source as the voltage. Next, for the source, for the voltage, the resistance is in series with the voltage source, that is Rs. That is the first point. For series feedback amplifier, always the source is voltage. If you are using voltage source, the resistance is in series with the voltage source. Next, this is series amplifier. Here the input is having mixer. Mixer is also in series. Here we have a mixer. This mixer is in series with the feedback network. Similarly, if it is a voltage, there we have a load resistance RL. If it is a voltage, the output sample is in parallel to the feedback network. Next, series is source voltage. Similarly, mixer is series. Next, sample output side sample is voltage. If it is voltage, you can connect in parallel manner, parallel or shunt manner. This is very important and basic thing. Always, if the this is a voltage, if it is series amplifier, the source is voltage. For the voltage source, the resistance is always in series. That is input side. Similarly, at input side we have a mixer. Mixer is in series. For series, mixer is series. Series connection is like this. Similarly, output is across load we are taking, that is V naught. Output side we have sample. Here we have a sample. The sample is voltage. Because the input is voltage, the sample is output voltage. Here the output sample is in parallel. For the voltage, the sample is in parallel connection. We have to represent. This is voltage series feedback amplifier. Similarly, we will go with the second one, current series feedback amplifier. Go to the second one, current series feedback amplifier. Current series feedback amplifier. Same amplifier A and same feedback network B. There, I am saying that series same as this. If it is series, always the source is voltage source. if source is voltage source, then the resistance is in series with the voltage source, that is Rs, and if it is series, the mixer is in series with the feedback network. Similarly, output we are taking at the load RL, output is taking at the load RL, output is like this we are taking, and if it is a current, the sample is in series. Current output is current, or it is a current, sample is series connection, and mixer is also series connection. Why? Because series, this is the second one, current series feedback amplifier. Here it is series connection, that is why voltage source, for voltage source the resistance is in series. Similarly, this is series connection, mixer is in series at input side. Similarly, output side we have a sample, for the current, the sample is in series. If it is a voltage, the output sample is in parallel connection, same as the first one. Similarly, go to the third category, that is current voltage shunt. Third one is voltage shunt, very important, voltage shunt feedback amplifier. Again I am taking A, that is amplifier open loop gain. Next I am taking beta, feedback network input, and we have output. This is a shunt connection. If it is a shunt connection, remember that if it is a shunt connection, the source must be current, that is is. If it is a shunt connection, the source must be is, and for the current source the resistance is in parallel, input resistance is in parallel connection, this is rs. Similarly, this is a shunt connection, that is why for the shunt connection, this is the mixer also in parallel combination we can take. For the shunt connection, we need current source, and mixer is parallel connection, or shunt connection. This is at input side. Similarly, at output side we have a load, resistance RL. Across load we are taking output, and again this is a voltage amplifier, that is why sample is parallel, same as the first one. Sample is the parallel combination. Again I am saying that for the shunt feedback amplifiers, source must be current source. For the current source, the input resistance is in parallel with the current source, that is Rs. Similarly, shunt connection means parallel combination. We can connect to the feedback network, and output is across RL we are taking, that is V0. Similarly, this is a voltage feedback amplifier. The output is parallel. Similarly, go to the fourth one, that is current shunt. Go to the fourth one, current shunt feedback amplifier. Last one, current shunt feedback amplifier. Same, you can take amplitude amplifier A and feedback network beta. This is input side, this is output side. Input side we have mixer, output side we have sampler, and again this is also shunt. For the shunt connection compulsory, the source is current source. Remember that. For the shunt connection, for all shunt connections, the source must be current, and for the current the resistance is in parallel, that is Rs. This is the input connection. Similarly, this is shunt connection, that is why for the shunt connection, the feedback network is in parallel, like this, and output is across load we are taking, that is RL, and this is the current source. You can connect in sample series. Sample is in series. This is the sample. For the current source, for the current amplifier, sample is series, same as the previous one. Sample is series, and similarly mixer at input side is parallel. Why? Because this is a shunt connection. Because this is a shunt connection. This is about the fourth one, current shunt feedback amplifier. For the shunt, the source is current. Source is current. For the current, the resistance is in parallel. Then next, this is shunt, so same as shunt connection. Similarly, output is RL. We are taking output across the RL V0. Similarly, and this is a current amplifier. So sample is in series. Sample is in series. This is I0. Then the output may be IF. Beta is equal to IF by I0. This is most important one. For all the four types, we have to draw the block diagram. Maximum 60 to 70% of answer is from this block diagram only we have to write. Next, we will write the examples for voltage series, current and feedback amplifier, and voltage and feedback amplifier, current series feedback amplifiers. This is the most important topic. Once again, you can remember that for the series, the mixer is always series. For the shunt, the mixer is always parallel. Similarly, for the voltage, the sample is parallel. For the current, the sample is series. Very, very important. Thank you.